Hey guys, Catlin here, helping you out with your homework, lesson 1 of Unit 8. We're looking at these areas of squares that have been tilted, and we don't know what their side lengths are, but we do know about the square that surrounds it, and so we can use some strategy to find out how much space is inside. So let's look at this first question here on your cool down. We're looking for the area and the side length of square ACEG. So just a quick reminder, square ACEG, just using a little geometry talk there, is this square that I'm highlighting in red. Okay. So if you connect the dots that are in the letters that they give you for that shape, it will create that geometric figure. All right, so ACEG is this square. We want to know how much area is inside of it. All right, so we want to know how much space is inside this red shaded region that I'm putting on here. Okay, and we also want to know how long its side lengths are. All right, which should all be the same because it's a square, as it says. All right, so we don't really have any way of figuring this out without the Pythagorean theorem because we haven't learned about it yet. But what we've been talking about is finding it by using some composite figure ideas where we know the shape around it and we take away stuff that we don't want. So our idea here is to think about this green square that surrounds it, find its area, and then from the area of that green square, we want to take away the area of the white ones that surround it. All right. So our strategy here basically boils down to this.
Jonathan Wilson, come to the office, please.
Okay. This big green square minus, we want to subtract, let's subtract 4, 1, 2, 3, 4 of the white triangles that surround our red shape, and that should end us up equaling the area of what's left over, which would be our smaller square that's shaded red, right? If we follow this strategy, we should be able to figure it out. Now we have everything we need to find the area of the triangles and the square that surround it, so this shouldn't be a problem. So let's knock this first one out. The big green square, if we combine the side lengths of 8 and 6 here, we know that this is a 14 by 14 square. And 14 times 14 is 196. I'll save you a little bit of time there. So it's 196 square units for the big green square. Now we want to take away the 4 triangles. Now we talked about this being a fast mental math kind of thing in class, all right? But I'll go over it slowly here in the video if you're watching and you need help. Now the area of a triangle is very simple. It's half times base times height, or base times height divided by 2. You can think of it that way. All right. Now, this is when the triangle is in the form like we see down here in the bottom. Let me make this in a gold color. Okay. So think of this as our triangle. The base and the height always surround the right angle. So you could think of the base and height as 6 and 8, and they're interchangeable. The base could be 8 and the height could be 6, like it is over here. All right. So we're going to do, in this case, 6 times 8 for base and height. And then we're going to take that product and cut it in half. Now, 6 times 8 is 48, and we're going to multiply that by half, and that's going to give us 24. So 24 is the area of each and every one of these white triangles. Now, there's 4 of them that surround our shape, and so that's why we're taking away 4 of them. So we're going to subtract 4 multiplied by the 24 square units that represent all 4 of our shapes, and that should give us our answer. All right. Now, 4 times 24 turns out to be pretty nice because that's going to be 80 plus 16, which is 96. So we got 96 square units there. We got 196 square units from our first square. And that difference is very nice because they make a difference of 100. So if our square here in red has 100 units squared, what would the side lengths have to be to make that area happen? And that would have to be a 10 because 10 times 10 gives us 100. So our area equals 100 square units, and our length equals 10 units. And those are our two answers for our cool down for today. I hope it's been helpful, guys. I tried to break it down a little slower than we went in class, but the expectation moving forward is those triangle areas should be mental whenever the whole numbers are as simple as times facts. All right. The expectation moving forward in your geometry classes is that you can do those in your head quickly if the numbers are that simple. All right. But that's the help that I've given you for today. I hope it's been useful for you, and we'll see you back in class tomorrow.